continuity of the last video of algebra and derivatives. We have to see now, we are going to see about multiplication and division. So for that multiplication, here the multiplying of 1 and 2, that is 1 is nothing but f of x minus f of c equal to x minus c f star of x, that is here. And next one is g of x minus g of c equal to x minus c g star of x. So f of x minus f of c and g of x minus g of c, we have to multiply this x minus c f star of x minus c g star of x. For that we combine this, multiply this f of x into g of x, f of minus f of x into g of x, and this one minus f of x g of x, and this one plus g f of x minus minus plus f of c g of c equal to, here x minus c taken as common means x minus c the whole square f star of x g star of x. So here f of x and g of x only written as this term, and these are taken to the equal to right side. So it will become as f of x g of x plus, and here also plus f of c g of x. This plus will change as minus f of c because we are taking equal to right side. So f of c g of c, and this is already in plus x minus c the whole square f star of x g star of x. Now what we do means, for our simplification we need f of c and g of c in this term. So we don't have this term, so we have to add and subtract these terms. So if we add and subtract, why we are subtracting both side means, if it is a equation equal to 0, we have to want here means we have to add and subtract. So if the subtracted term here will go means there will get addition, or otherwise if we subtract both the terms, or otherwise what I should say means, if it is addition here and if it is subtraction here means subtraction x, this subtraction x means what, if it is my plus taken to equal to other side means we get minus x equal to minus x. So only we are subtracting here both the terms. So minus f of, I hope you all understand, because we have splitted the equal and the terms are in, if it is for your wish, if here f of c g of c, if you add and subtract means we get this values, and this added values will go to equal to right side means it will goes to minus value. So then what we do means, this can be written as f g of x minus f g of c equal to this, the both terms, here the first term and the here the second term and the fourth term, we have fc as a common. So f of c g of x minus this two terms, f of c as common means we get g of x minus g of c, and this first and last terms we get g of c as common. So f of x minus f of c plus x minus c the whole square f star of x and g star of x as it is common. Then what do means, f g of x minus f g of x we taken as common means, then what we do means we have to substitute instead of this we can substitute x minus c g star of x plus g of c x minus c f star of x. So if we take x minus c as a common value means we get f c g star of x plus g c f star of x plus minus c square f star of x g star of x. So we find out this, we have to substitute the derivatives values. So f dot g dash of c equal to limit x tends to c f of g x minus f of g c divided by x minus c. We have to substitute means limit, instead of this we can substitute these values. If we substitute means taking x minus c as a common means these are getting cancelled each other. So left over terms are f of c g star of x plus g of x g of c f star of x plus g x minus c, because here x minus c is getting cancelled, one x minus c is getting cancelled, and the left terms is x minus c f star of x g star of x. So if we substitute the limit means we are substituting the limit values of each term. Here f of c is a constant, so we have to take on other side f of c equal to limit x tends to c g star of x, and here g of x is constant, so limit x tends to c f star of x, and here the if we substitute the limit means this will get the terms as 0, value as 0. So the left terms are, if we substitute here means substituting the limit, this will goes to 0, and the left terms of g star of c plus g of c, and this is f star of c, because we are substituting instead of x c. So the left or g star of x can be written as g dash of x, and f star of c can be written as f dash of x. So if we take f here, how we write means g gc gc and f dash of c plus fc g dash of c. So this is the given in question. We have to prove. Next what we do means we have to prove for division. So for that division, f by g, f of g divided by g of c minus f of g divided by g of c, f of g divided by g of x minus f by g, that is nothing but f of x minus f of c divided by g of x minus g of c. This is written in this form, and it is f of x minus divided by g of x minus f of c divided by g of c. So we have to cross multiply f of x g of c minus f of c g of x divided by g of x g of c. So instead of that, we also here subtract and add and subtract the f of c g of c for our simplification. So here subtracting, here adding means we get the g of c as common means f of x minus f of c. Here minus f of x as taken as common is g of x minus g of c. So g of c, this can be written as x minus c f star of x minus f of c x minus c g star of x divided by g of x g of c. So x minus c as a common means we get taking as a common means we get g of c f star of x minus f of c g star of x divided by g of x g of c. So we get these values and we have to differentiate. So f by g dash of c equal to limit x tends to c f by g of x minus f by g of c divided by x minus c. So here the limit x tends to c means we get x minus c g of, instead of this we have to substitute x minus c g of c f star of x minus f of c g star of x divided by this value, and this two are getting cancelled, and the left terms of g of c f star of x minus f of c g star of x divided by g of x g of c. So substituting the limit value, instead of taking the constant g of x and f of x outside and substitute x tends to c means we get f star of c minus f of c g star of c divided by g of c g of c. So it can be written as g of c f dash of c minus f of c g dash of c divided by, here having two terms, that is modulus of g c of whole square. So f of f by g of c exists, f by g is differentiable at c, and f by g dash of c equal to this. We have proved that this g of c not equal to 0. So hope you all understand. Thank you.